Hi everyone. Before getting into this project, let me quickly introduce myself. My name is Yosai. I recently done my graduation. Now I am working as a data analyst trainee in Trinity. And today's project is about ABC call volume trend analysis. Basically, the project is about analyzing the data on inbound calls received by agents in ABC company which operates in insurance sector. So we need to analyze this particular ABC company is inbound calls data and find the valuable patterns and insights to help them to attract, engage and delight customers, turning them into loyal advocates for business. Let me show you the data I have downloaded from the project, Trinity's project. Here is the original data, raw data which I have downloaded. Before getting before making any further changes to this original data, we need to create a copy of this original data. So in case if we make any mistakes, okay, we can retrieve the original data. So here you can see this is the copy of this original data. So when it comes to data cleaning part, there is not a requirement for data cleaning on the given data set, as it contains some blanks, but we don't need to remove them. And there are also no duplicate rows found in the data set. So from the original data set, I have arranged in a formatted as a table without removing or doing any data cleaning process on the original data set. Before getting into the tasks, let me quickly give you something that you need to understand. Here you can see the variable call status has three three things, which is calls abandoned, answered and transfer. You need to understand these three things before getting into the tasks. I copied some of the data from this data, from the copy of this data. Here you can see I copied some of the rows to give you brief about what is transferred and abandoned and answered. Here you can see answered and transferred call status are from the same customer phone number. Here you can see customer phone number column. Here you can see both the numbers are same, and they have different call status. One is transferred and answered. It the thing is, if a customer makes a call and if he is not satisfied with the agent's answer, uh, he can be transferred to another superior where he can get the satisfied answer. So this might be, here you can see in the call status of transfer, where the client where the customer's question is not answered completely, so he can transfer to another agent which is senior. So they might, so his senior may answer the customer's question. So we need to consider both these calls as single call. We don't need to consider both as individual calls. We need to consider both of them as single call. And when it comes to abandon, there is no agent is answered to such calls because of there is no time for them to answer other calls, so they ignore because of lack of human resources. Here you can see this is also same as I said earlier. So we need to consider the transfer and answer call status as a single call, and abandon as a call which is not taken by the agents or not answered by the agents. So when it comes to task 1, what is the average duration of calls for each time bucket? So we need to calculate the for each time bucket what is the average of average duration of calls that is received by agents. So I used a pivot table to get the answer. Here you can see time bucket is in rows and call status, and I have changed this value field settings to average and filter the call status to answered. So as I earlier said, answered and transfer calls are taken as a single, so I not consider the transfer calls, and abandoned calls are also not considered because they are not answered and they have no data. Here you can see this is the call which is not answered, which is abandoned. The call duration is 0 seconds, so we don't need to consider the abandoned and transferred call status. So I only considered answered call status and calculated the average of call seconds. Here you can see the on an average on total 199 seconds is the average duration of calls. And when it comes to task 2, can you create a chart or graph that shows the number of calls received in each time bucket? And here also I used the pivot table to get the things done. Instead of, here you can see in the task 1, I used the average in the value field settings. But when it comes to task 2, here we need to count the number of calls received in each time bucket. So I used I changed the value field settings to count. That is the only change. That is the difference between the task 1 and task 2. Here also the same thing. Here we only consider the answered call status and the remaining two are not considered. And I also inserted this chart based on this data. Here you can see the 12 to 13 time bucket has the highest received the number of highest calls, followed by 13 to 14 and followed by 11 to 12. This is about task 2. And when it comes to insights explanation, here you can see the Word document that I have explained what I said from this data and chart. Here you can the insights, read the insights. And when it comes to task 3, what is the minimum number of agents required in each time bucket to reduce the abandon rate to 10%? Here I again used the pivot table, inserted pivot table, and count the call status, but on variable wise. Here you can see the for each time bucket the number of abandoned calls, the number of answered calls, and the grand total. This is the grand total for 23 days, and I have calculated the per day. Actually, this data is given for 23 days, so I calculated for day. This should be divided by 23 to get this per day. You can see 23 divided by 23. These are the assumptions that are given in the question. Here you can see, let me zoom in. Total working hours are 9 and they have the break 1.5 hours and the working hours is 7.5, on from which they only spend their time with the customers are 60%. So of 7.5 into 60% is which is 4.5 hours. The agent spends their time with their customers. And the average call duration from the task 1, as here you can see, from the task 1 we calculated the average of calls, call duration 199. I used that call duration. Here you can see So based on the 199-second call duration for each call, an agent can speak up to 18 calls per hour. That is his capacity based on the 199 seconds average call duration. So I have calculated that. Based on that, I have made some calculations to answer the task. Here you can see this is the per day abandoned calls. This should be distributed in these percentages or in these numbers. So I have I have made that calculations. This per day abandoned calls should be distributed based on these numbers. I have made those calculations, and when it comes to answer call, the same method is followed. This should be distributed with these numbers, and when it comes to total calls, I have just added the abandoned calls and answer calls, and we need to pay attention that these calculations are per day calculations for day shift, that is 9 a.m. to 9 p.m. These are belongs to day shift calculations and per day, not for 23 days. These are for 1 day calculations. So here you can see the percentage. Based on these numbers we have calculated the percentage. So these are the total calls that agents received, including abandoned and answer calls. These are the per day calls. If you want to maintain the 10% abandon rate, so the agents need to answer the 90% of the calls. So 10% of the calls are not answered. These are the calls that should be left unanswered, and this column should be subtracted from this column to get this one. Extra calls needed to be answered. So these are the extra calls that are needed to be answered by the agents to maintain the 10% abandon rate. And as you can see, an agent's capacity per hour is 18 calls. So based on that, I have calculated this one is divided by 18, and here you can see the 11 agents are required to answer the 198 calls in the time bucket. Total number of agents. Here are the total number of minimum agents required in each time bucket to answer the inbound calls with 10% abandon rate. Here you can check. If you multiply the minimum agent number with the number of calls, which is 18 per hour, here you can see you can get a number. When you sum up of all those numbers, you can get 4573, which is 90% of 5081 calls. 5081 calls is the total number of calls per day. If you so 90% of those calls are answered with this minimum number of agents. Here you can check whether these are the correct required agents or not. Here is a check. And this is about task 3. When it comes to task 4, propose a manpower plan for each time bucket throughout the day, keeping the maximum abandon rate at 10%. Here are the calculations. This is the picture that I have copied from the project. So for the task 3, we have planned to manpower for day shift. Now we are planning manpower for night shift, which is 9 p.m. to 9 a.m. Here you can see the distribution of those received calls based on the time buckets. For every 100 calls that are receiving in the daytime, we can receive 30 calls in the night. Per day total calls customers make are 5081 here, which is taken from the task 3. Here you can see we also calculated with the total calls received in a day are 5081. So based on that 30% of those calls are made during the night shift, which is 1524. These are the total calls received during the night shift from 9 p.m. to 9 a.m. and those calls are distributed based on these time buckets. And here you can see the taken the time buckets. Here you can see from here the next study starts, and from the picture I have arranged the data and also calculated the percentage, this distribution percentage, and I distributed these calls based on this percentage. Here you can see the calculation. This one is distributed. This one is distributed based on this 10%. These 1524 calls are distributed based on this given data. When you sum all this, you can get the total 1524 calls that night shift agents are receiving. I have copied this distributed data to this. Here you can see this is the data that we have calculated in this. To make it clear, I have made some calculations down. Here you can see these are the calls received by the agents in night shift for each time bucket. We need to maintain the 10% abandon rate, so 90% of the calls are answered by the agents. Here you can see this is the 90% of 152, that is 137. These are the calls that needs to be answered for each time bucket during the night shift. So these are the required agents. If we based on the calculations or assumptions we made, that if an agent makes an 18 calls per hour, so during this 1 hour to make 137 calls we need 8 agents. For each agent they make 18 calls per hour. So these are the calculations for different time buckets. As you can also see that this is the next day time buckets. And when it comes to for the entire day manpower planning, which is from today's 9 a.m. to tomorrow's 9 a.m., that is 24 hours time. This is the manpower planning uh, with 10% abundant rate. Here are the required number of agents to answer the 90% of the calls that are received, which is the combination of the task A and task which is the combination of task 3 and task 4. Here you can see the minimum agents required combined with this number of agents required. This is the total number of agents required throughout the day. Here you can see the chart from this data. That's it about the project 4. Hope you understand the details. Thank you.